So let's open back up to the slides. And we're going to go to this. So we'll just be finishing off the anti-differentiation stuff, right? And the last big thing about anti-diff is going to be this rule called integration by recognition, or basically just like doing like finding the derivative and then doing the opposite. So here, Cav, can you tell me the derivative of this function here? Can you show, how can you show that this is the derivative?
It's u dash on u, so like since u is x squared plus 1, u dash is 2x on 2x plus 1.
Yeah. How would I be able to show that though?
How do you show that? You can use chain rule.
Yeah. So here we let u equal x squared plus 1, and then we will do y equals ln of u. So then, what's the derivative of this one? du on dx.
2x.
And what is dy on du here?
1 on u.
1 on u. So this is
Mhm.
using the chain rule. F dash of x must then be equal to du on dy on du times du on dx. And then what do we get from there?
Or 2x on u and use x squared plus 1.
2x on u, and then 2x over x squared plus 1. So here, the reason I showed so much there is because you need to show everything, right? You need to show everything with this question. You need to show like as much as possible. So here, I'm literally showing the formula. I can't just say, oh yeah, this is the derivative because this is the derivative. I need to show that this is the formula. I'm doing a show that you go back to the very basics. Here, we're using the very basics of the chain rule. So we let the u equals with the y equals, and then we solve it that way. Now, it says here, evaluate the integral from 0 to 2x over x squared plus 1. Now, this isn't a function we can differentiate, but there's a reason these two questions are linked together, yeah? If we know that d on dx of ln of x squared plus 1 equals
I know how to do
2x
that.
over x squared plus 1, yeah? That means the integral of this one must be equal to x squared plus 1 dx.
Take it off.
Take my top off. Okay.
Okay, let me just mute that really quickly. Yeah, there you go. So ln of x squared plus 1 plus c. Yeah? Now, how do I get to this result? That's the real question. Yeah? Remember, differentiating and anti-differentiating are reverse processes. You can think about it as multiplying it by the inverse function. Yeah? So like if we do like e ln of x, yeah? Right? Do you see how these two cancel out? The same thing with the if we integrate this side, if we integrate the right-hand side, yeah? The integral and the d on dx cancel out with each other. So we're left with this expression here. So does that make sense for everyone? What part doesn't make sense, Carl?
Bro, I actually don't know. I don't know what's been happening.
So remember how differentiation is the anti-differentiation is the reverse process of differentiation?
Yeah.
Well, if I know the derivative of ln of x squared plus 1 equals 2x over x squared, that means if I anti-differentiate this function, I should just get back to the original, correct?
Yeah.
Does that make sense?
Yeah.
So that's like the idea that I want to go through. And here, the reason we've linked these two questions together is because now this integral on the right hand side is very similar to this one over here. So, right, I have the integral of 2x over x squared plus 1 dx equals ln of x squared plus 1 plus c, which means here, right, if I can take out the 2 from here, yeah? So I can have it as 2 integral of x x squared plus 1 dx equals ln of x squared plus 1 plus c. Yeah? Which means I can, this is literally the same integral. It's just 2 times this integral. So that means I can find out what this integral is without the boundaries as the integral of x squared plus 1 dx equals a half ln of x squared plus 1 plus c. Yeah? The c doesn't change because the c is just some arbitrary constant. Yeah? The c will, we'll get different c values, but you can just leave it as plus c. Yeah? Does that make sense to everyone? Is that all good? The logic that goes behind that process. Okay. Carly, Kib, me. Okay, everyone's chill with that. So, now that I know that the integral of x over x squared plus 1 dx equals a ln of x squared plus 1 plus c, right? That means here the integral from 0 to 2 x over x squared plus 1 dx equals the integral equals a half ln of x squared plus 1 2 to 0. Yeah? We can drop the plus c because now we're using a definite integral. And to evaluate this one, well, we'll just do our g of 2, take g of 0, right? So we'll define g of x as a half ln of x squared plus 1. And we'll have a g of 2 equals a half ln of 5. G of 1, g of 0 equals a half ln of 1, which is just 0. So that means here, we're just left with a half ln of 5, take away 0, which is just a half ln of 5. Does that make sense for everyone? Does that process of integration by recognition make sense? What's up?
So by integrating it, like, haven't you just proved that the original function is log e x squared plus 1, but you've just got a plus c because you've integrated it?
Yeah.
Okay.
So, does anyone else have any questions? Is that all good for Mia, for Carly? For everyone? Okay, sure. So, here, how can I show that the derivative of this one is negative 1 over sine squared of x? Mia, do you know how I'd be able to show that?
No.
Okay, that's fine. We use the quotient rule, yeah? So here, we let u equal cos of x, and v equals sine of x, yeah? If we look at our quotient rule formula in our formula sheet, we'll do du on dx equals negative sine of x, and dv on dx equals cos of x, yeah? So that means here, f dash of x of this integral is just going to be v times du on dx, so sine of x times negative sine of x, take u times dv on dx, which is cos of x times cos of x, over v squared, so sine squared of x. Yeah? This whole expression simplifies down to f dash of x equals negative sine squared of x, take cos squared of x, over sine squared x. And here, we need to show that this part equals 1, because some of you haven't covered trig, you won't know this identity of sine squared x plus cos squared x equals 1, yeah? So sine squared x plus cos squared x equals 1. So if I factorize out the negative here, sine squared x plus cos squared x over sine squared x. So we get this sine squared x plus cos squared x at the top, and we know that's equal to 1. Always. It's always equal to 1. So we get here negative 1 over sine squared x as our final answer. Does that make sense for everyone? Okay, that's for Carly. Okay. Now we're going to use, so here it says hence evaluate this. So we know that cos of x over sine of x d on dx is equal to negative 1 over sine squared of x, right? What is the integral expression I can write out here, Carl? How can I rewrite this using the integral rather than the derivative?
Bro, what?
Like, remember in the previous part here how I rewrote this whole thing using an integral rather than a derivative?
Oh, okay. Would it be cos x over sine x plus c?
Yeah, so cos x plus sine x plus cos x over sine x plus c equals, what does that equal?
Equals the integral of negative 1 over sine squared x.
Yeah, perfect. So does that make sense for everyone? And then we want it to look like this integral, which means we can either, like, we can take out the negative, or then we can multiply both sides by negative. So here, if I take out the negative, this becomes positive. So we have negative the integral plus 1 over sine squared x. And then what I can do, I have this negative 1 over sine squared x dx equals cos x over sine x. What the fuck was that?
Is it raining for you? Or is that thunder?
Yeah. So then we can multiply both sides by sine. So we get here 1 over sine squared x dx equals negative cos of x over sine of x plus c. Yeah? So now we have this integral. We can just use we can just plug in those boundaries. 1 over sine squared x dx. And we get negative cos of x over sine of x pi over 2 pi over 4. Yeah? From here, right, what can we do from that point, Mia? How can we evaluate the expression that is on the right?
Do I sub in both of them?
Yeah, so here we can just write down g of pi over 2 take g of pi over 4. So we'll just say g of x equals negative cos x over sine x. So what is g of pi on 2 here? Anyone know what g of pi on 2 is?
Is it 0?
0? And Carly, what's g of pi over 4?
Oh, wait. Negative root 2 on 2 divided by root 2 on 2.
Yeah, what does that simplify to?
Negative 1.
Negative 1. So we get here 0 take negative 1, which is just 1. Does that technique make sense to you guys? So this is what we call integration by recognition. Basically, we find the derivative of 1, yeah? And then we manipulate this so we can find the integral of what we want. Yeah? It's what mathematicians call, I don't know what mathematicians call it. They call it something. This one here is a little bit different. Yeah? So here, it says find f dash of x, and hence find f ln kx dx, where k is a positive real number. So, Kavinu, what is the derivative of this function? How can I find it?
It's a product rule. So yeah, so u can be x and v can be log e bracket kx.
Yep.
U dash is 1.
d1 dx, d1.
Yeah, sorry. dv on dx is k on kx, which is
just
1 on x, simplified.
so 1 on x, yeah?
Mhm.
So then here, what is the full expression of this derivative?
Well, x times 1 on x plus 1 times ln of kx.
So we're just left with this, and if we simplify, we get 1 plus
Plus.
ln of kx.
Yep.
So that's what we get as our derivative here. We get here 1 plus ln of kx. Now, we're still going to use the same technique here, right? Here, we know that the d on dx of k ln of kx equals 1 plus ln of kx. So, Mia, what's the integral expression for this one?
Maybe the f of x plus c.
Yeah, so it could be just like k ln of kx plus c equals, what does it equal?
The integral of 1 plus ln of k of x dx.
Yeah. So it says here, hence we want to find this part, yeah? So we've done this. Now, there's an interesting property of the integral where we can distribute the integral to each one of these expressions. So here, I can rewrite this as x ln of kx plus c equals the integral of 1 dx plus the integral of ln kx dx. Does that make sense for everyone? Is that all good? Does that property make sense? So I'm just distributing that integral to each term. Okay. And here, do you see that this is the exact thing that I want to find the integral of? So, right, here I have ln of kx plus c equals the integral of 1 dx plus the integral of ln kx dx. If I want to simplify this one, what's the like here, I only want this one on this side. So, Mia, I'll ask you, what is the integral of this function?
Of 1?
Yeah.
X.
X, that's it. So it's just x ln of kx plus c equals x plus the integral of ln of kx dx. Hence, what we can do is we can subtract x from both sides, and then we get here the integral. Why is my pen doing this? We get here the integral of ln of kx dx equals x ln kx, take x plus c, right? Does that make sense? Does anyone have any questions about that? Thumbs up, thumbs down, thumbs to the side.
You know, there's no thumbs to the side, right?
Yeah, but I just say it to be funny, okay? God forbid. God forbid, bro.
Yeah, that's fine.
So, here, right? with this expression? I'll ask Carly, how can we differentiate this function? How can you find f dash of x for this function?
So you make u x squared,
So u equals x squared, yep.
and then v equals ln of brackets k of x,
Yep.
kx, and then du on dx is 2x.
Yep.
And then dv on dx is 1 over x.
So then how can we write down f dash of x?
So then it'd be x squared times 1 over x plus ln kx times 2x.
And this just simplifies to x plus 2x ln kx. Yeah? So then it says here, hence find the integral of x ln kx. Right? So I'm going to write the integral expression. So here we're told d on dx of x squared ln of kx equals x plus 2x ln of kx. So, Kavinu, how can I write the integral expression of this one?
The integral of x plus 2x ln of kx dx is equal to
What are you forgetting?
caret.
Plus c
Oh, okay.
equals, what does it equal?
X plus 2x. Yeah, the integral from x plus 2x.
Dx. So we get this as, so we get x squared ln of kx plus c equals the integral of x plus 2x ln of kx dx. So then I'm going to do the same thing. I'm going to distribute the integral here. So I get integral x dx plus the integral 2x ln of kx dx equals x squared ln of kx plus c. And let me just rewrite it up here. So I get x squared ln of kx plus c equals the integral of x dx plus integral 2x ln of kx dx. Yeah? So, Mia, do any of this thing look like the integral that we want?
Uh, 2x times ln kx.
So how can I make this 2x ln of kx look more like this?
Divided by 2.
Yeah, or we can just bring out the 2 here. So here, right, we can write this as 2x ln of kx plus c equals, what's the integral of x, Carl?
I don't know, bro.
So here it's x to the power of 1. So we do add 1 to the power. So we have x to the power of 2. And then divide by that new power. So we get 2. Plus 2 integral x ln of kx dx. Remember, you have your formula sheet in front of you. I call the chemistry data book the chemistry student's best friend. For methods, your formula sheet isn't your best friend, but it's a very good friend, you know, especially for integration. So here we get this one, and we have our exact integral expression. So Kavinu, how can I rearrange this so I have this integral by itself?
Well, you can minus the x squared on 2
Yep,
firstly.
so we get x ln of kx, take x squared over 2 plus c equals 2 integral x ln of kx dx. Then
Then
what?
you can divide it by 2 to get the one you want.
Yep, so we get x squared ln of kx over 2, take x squared over 4 plus c equals the integral of x ln of kx dx. So, does that make sense for everyone? Essentially, right, this technique, how I go about using it is I think about what is the integral that I want, yeah? What is the integral that I want? And by understanding what the integral that I want here, then I can say, well, like knowing the integral that I want, I know I should be looking for that when I write the integral expression of the f dash of x, right? So, originally it's the d on dx of the plus c is never impacted. Plus c is an arbitrary term, yeah? So, it's a bit weird to think about it, but you can divide plus c by 2, but we don't tend to do that, right? The reason being is because when we divide it by 2, then it becomes like, how do I explain it? You can think of this plus c is different to this plus c, yeah? So this is c1, and this one here is c2. And what I'm saying here is that c2 is equal to c1 divided by 2. But why would I write c1 divided by 2 when I could just do c2, yeah? So the point is to just simplify the expression. That's why I keep it as just plus c. Because regardless of whatever c is, I'm still going to have that constant in the back, right? It's a bit strange for it's a bit strange to see, I guess. Is there a better way to think about it? It's like you can think about it as almost a rule, yeah? We don't mess with the plus c. The plus c will change by itself, yeah? So you just don't want to mess with the plus c. Think about it, like I'll just give you the general rule. Don't mess with plus c, yeah? It's like the don't trust your ex. Don't mess with the plus c. What's a good way? I don't know a good phrase. Can someone come up with a good phrase for the why you don't mess with your plus c? Because C be dangerous, But anyway, time to get back.
Move on, bro. Move on.
Okay. These last two here is basically, do you know how to use the calculator? So you don't need to be able, like, if you're given something that's not on the formula sheet, it's either you have to use recognition or you use your calculator. So let me pull up my best friend for methods. My best friend. Let me just see. Is he gonna load? Is he gonna load? Load up. Load. Right here. The calc over here. So here, right? If we want to evaluate, we do 4, 3, right? Menu 4, 3 brings up our integral. And here we do 1, 2, and here is the integral I want to evaluate. So it's going to be 1 over the square root of 1 take x squared dx. And what? And I wrote it wrong, that's why. So let me just write it correctly. So it's going to be x squared plus 1. Yeah? And if I want to evaluate that, that's what this becomes. That's the whole point of this last task. It's just to point out that you can use your calculator to do these things. Yeah, so anyway. So, here, can someone tell me what, using your calculator, your calc, right? What is the exact value of this one? What's the exact value of this one? Make sure you use your calc. Calc is short for calculator. So I'll ask Mia, what did you get as your exact value for this one?
Give me 1 second.
Oh, good.
exact value?
Yeah, just the exact value.
Oh, e to the power of pi of 2 minus 1.
Minus 1?
Oh wait, oops. I didn't fully do it.
Carly, have you written down what the have you found
I
out what
got
it
e to
was?
the power of 2 all over 2 plus half.
That's half? Yep, perfect. So if I typed it into my calc, this is what it would look like on my calc. This is what it looks like on my calculator. Does anyone have any questions about using the calculator whatsoever? Is that all good? Thumbs up, thumbs down, thumbs to side, thumbs all that. So now we're looking at area calculations, yeah? Essentially, right, to find the area between two curves, so here we have f of x and g of x, we find, right, we evaluate here the integral between f of x take away g of x, yeah? So you can think about it as f of x is this full area, yeah? And so that's the area of f of x between a and b, yeah? And I'm taking away the area over here. So that means I should just be left with the green area overall. Does that make sense, like logically? That like I'm taking like to find the area, I just take one area away from the other. Is that all good? Does that make sense? The logic behind that. It's all very graphical. It's very nice. Very chill. So here, right, I want to find the area bounded between x squared and y equals 2x. Yeah? So if I draw out this curve, I'm going to have here, this is what y equals x squared looks like. Yeah? And this is what y equals 2x looks like. Now, Kavinu, which part is the bounded area, right? If I say like, if I have to give you like, tell me what the bounded area is in this one.
The part where they both like intersect
Yeah.
on the right. Yeah, that part. Yeah, that part.
So this part's the bounded area that they're asking me. So the bounded area is the area between the two curves. Yeah. So here, the integral that I type. So first, I have to figure out, well, what are my boundary points? And it's essentially where they intersect each other. That's where I'm going to be integrating from. So here, how do I find when they intersect each other, Carly? How do I find when two graphs intersect each other?
Has it?
This is a Kaz, yeah. What can we do by hand?
I don't know. Do you make them equal to each other?
Yeah. So we have here
Oh,
x squared equals 2x. And then if I solve this one, I get x squared take 2x equals 0, which means x, I get x take away 2 equals 0. Hence, x is equal to 0 and 2. So here we found both of the boundaries. These are both of the boundaries here, yeah? So, Mia, how would I write out my integral for this?
I don't know.
Okay, so you do the boundaries from 0 to 2, and then you do the top function. So the top function is 2x here. 2x, take away the bottom function, which is x squared dx. And then we do our fundamental theorem. So if I clear everything here, I'm just going to do 0 to 2, 2x take away x squared dx. We get here x squared take x cubed over 3 squared 0. We get g of, then we do here, we go down here, we do g of 2 take g of 0. We get g of x equals x squared take x cubed over 3. We get g 2, which is 4. Take away 8 over 3, which is just 4 over 3. And we get g of 0 equals 0. So here we get 4 over 3 take 0 equals 4 over 3. So the area between these two curves is going to be 4 over 3 units squared. That's the bounded area between these two curves. Does that make sense for everyone? That's the bounded area between those two curves. Does that make sense for you, Mia? Thumbs up. Oh, yeah, I'm just gonna air it out then. Anyway. Like, the big thing that you notice is that you need a graph in order to do these. You need a graph in order to understand what the top function is and what the bottom function is. So here, if I sketch this one, yeah, it says calculate the area bounded enclosed by the curves with the equation y equals x squared plus 1 and y equals 4, take away x squared, and the lines x equals 1 and x equals 2. So this is what these two curves look like. So we start off up here, and we get this first curve. And this curve is going to be y equals x squared plus 1. This over here is going to be my second curve, yeah? This is going to be y equals 4, take away x squared, right? That's between x and negative 1. So it also needs to be between this and this. So here, we're ultimately trying to find this shaded area here. So, I'll write out the first part. So it's negative 1 to 1. Carly, what's the top function here?
Um, 4 minus x squared.
Yeah. And Kavinu, what's the bottom function here?
X squared plus 1. Wait, what?
Thank you, Cav.
Yeah, what they said.
Oh, Ron. Sorry.
No, it's all good. It's all good. You're just getting too excited about it. So here, right, if we simplify this one, we get 3 take away 2x squared dx, right? That's the thing we're trying to find. We're trying to find the integral of to find this bounded area. So then what we can do is, well, we can evaluate it first. We get here 3x take away 2x squared over 3 from 1 to negative 1. We get g of x. Oh, so like, let me move all this stuff up here. We get here the integral of 3 take 2x squared, negative 1 to 1 dx. We get here the 3x take away 2x squared over 3 from negative 1 to 1. Here we get here g of 1 take g of negative 1. If I do a little aside, we get g of x equals 3x take away 2x squared over 3. Oh wait, 2x cubed over 3. We do g of 1, which is just 3 take away 2 over 3, which is just 7 over 2, 7 over 3, sorry. And we get g of negative 1, which is just negative 3 plus 2 over 3. Here we get negative 2 numbers, negative 7 over 3. So here we get 7 over 3 take negative 7 over 3 equals 14 over 3. So here, the bounded area between these two are 14 over 3 units squared. Does that make sense to everyone? Okay. Chili. So, here, right? I want to draw, so it says I want to find the bounded area between x cubed and x. So I'm going to show you two ways on how to do this one. So here, we'll first draw out x cubed. This is what x cubed looks like. And here, this is the graph of x, right? The bounded area I want to find here is this and this. So, Mia, what's the intercepts between these two curves? How can I find these intercepts?
It would be x equals 0 and x equals plus minus 1.
So here we get 0, we get minus 1, and we get 1 over here. Yeah? So I want to write out the integral for this. Yeah? There's two ways I can do this. I can either see that the area A is going to be equal to the integral of -1 to 1 x cubed take x dx. I mean, wait, 0 dx. Yeah? Now, Kavinu, why can I not just write it from -1 to 1? Right? Why am I writing from -1 to 0?
Because there's no area at 0. At 0, it's 0. Does that make sense? I don't know.
No. It's because the
No.
top function changes. So originally, it's x cubed is the top function, and x is the bottom one. Yeah? But then, when we switch over from 0 to 1, the function changes from 0 to 1. Now it's x take away x cubed dx. Yeah? Which we can evaluate these two. We can do here x to the 4th over 4, take x squared over 2 from 0 to -1, plus the integral from x squared over 2, take x to the 4 over 2 from 1 to 0, right? So to evaluate these two, I'm going to do two asides. So here, this is A. We know A is equal to g of 0 take g of -1 plus, right? So that's our first part. That's this side of the integral. And then over on this other half, I'll do f of 1 take f of 0. F of 0, which is this second half of the integral. Yeah? So then if I do g of x equals x to the 4th over 4, take away x squared over 2. We get here g of 0 is just 0. And we get here g of -1 equals g of -1 equals -1/2, right? We do here f of x equals x squared over 2, take x to the 4th over 2, wait, x to the 4th over 4, sorry, this is over 4. This is f of 0 equals 0, and then f of 1 equals 1/2. So here, what we see is we see that A, right, which was g of 0, take g of -1, plus f of 1, take f of 0. We get this simplifying to 0, take away -1/2, plus 1/2, take away 0, which means we just get 1. That's my answer. So does that make sense? Here, the bounded area between these two curves is 2 units squared. Does that make sense to everyone? So the big thing here is I always need a sketch. Always, always, always I need a sketch in order to do these boundary problems. Yeah? So here, right, I'll ask Carly, what's the top function here? And what's the bottom function?
Sine of x is the top.
Yep.
Wait, sine x is the top.
Yep.
And then cos x is the bottom.
Yeah. So that means here, if I wanted to write out the integral, I do sine x, take away cos x, right? These intercepts here, I want to find, I just have to let them equal to each other. So cos of x equals sine x, right? We know that this is equal to 1 take equals tan of x. Have you? Wait, I've done this with Mia before. I don't know if Carly has seen this. Have you seen the solutions for trig functions before?
Huh?
Have you seen like solving trig functions?
What do you mean by that?
Like can you solve 1 equals tan of x?
Oh. I think. I don't know.
Okay. So this is just x equals pi over 4 comma 5 pi over 4. I'll discuss the solutions with you later. Does that make sense for you, Mia and Kavini? Okay. Don't worry too much about that, Carly. We'll look at this. We'll look at this in a bit. But here, the area of this is equal to pi over 4, 5 pi over 4, sine x, take cos x, dx. So, here, what is the integral of sine, Kavini?
Negative cos x.
Yep, so it's negative cos x. And Mia, what's the derivative of cos x?
Is it sine x?
Yeah. There you go. Negative or. So we get 5 pi on 4, pi on 4. So that means here, we do here the f of 5 pi over 4, take for f of pi over 4. So here, if I do that on the side, I do f of x equals negative sine of x, cos of x. When we look at the exams, you have a lot more space to do this, I swear. Take away sine x. Right, so that means here f of 5 pi over 4 is just going to be root 2 on 2 plus root 2 over 2, which is just root 2. And then we have a f of pi, which is just negative root 2. That means here we get root 2, take negative root 2, which means we just get 2 root 2. Yeah? You guys can do the working out for those ones, right? Like the f, they're plugging in the f's and plugging in those ones. Those aren't too hard, because it kind of just looks like a big mess here. Yeah? But trust me, when we start looking at exam questions tomorrow, we'll see it a lot more clearly. So we've got 2 more things, and then we've essentially done all of integration. Yeah? So here, right? What is f inverse of x, Carly? How can we find f inverse of x?
Is it 1 over x plus 1?
Yeah. Wait, what?
Is it not?
So that's the derivative. What about the inverse?
Oh, fuck me there. Bro, wait. Bro, I don't know. Ask Mia.
I don't know either.
Convenient. What do you do?
Well, x is equal to log e y plus 1. Then you just rearrange it for y.
Yeah. So you
So,
just swap x.
do you want me to do it or do you want to?
Yeah, you can do it.
Okay, so you raise it to the power of e, so base e. So e to the x equals y plus 1, then you minus 1.
So you get y equals e to the x take away 1. You guys remember that, right? I'm just gonna guess yes. So here, if we were trying to sketch these ones, we get this function that looks something like this, right? Oh wait, no, that's wrong. It's gonna look something like. So we have here our asymptote at x equals -1. We have our sketch, which looks like this. We also have our asymptote at y equals -1, and our sketch that looks like this. Yeah? So we have these are our two functions. This is our e to the x take away 1. This is our ln of x plus 1. Yeah? So it says find the integral from 2 to 0 of this one. Yeah? So let me sketch this out a bit nicer. So let me turn the pen on, turn it on, erase everything. I'm gonna make a nicer sketch. So here we'll use different colors. So I'll actually make it big. That's what I'll do. I'll make a big sketch. This big sketch. So here. So we'll have. I'll label the asymptotes like this. So here, this asymptote. So this is the ln one. Yeah. And here we'll have. Fuck. Anyway. Here is the E one, yeah? So, it's asking me for what the integral from 0 to ln of 2 is for E, yeah? So it's asking me for that area. Does that make sense to everyone, yeah? Is that all good? Thumbs up, thumbs down, thumbs to the side, thumbs all around. Okay. So here, how can I find this integral, right? I know that the rule of this one is e to the x take away 1. So I'll ask Mia, how can I find the integral to it, the integral of this one?
Is it just e to the x plus, minus x?
Yeah. So ex minus x, L of 2, 0, we'll do here g of ln of 2, take g of 0, we'll do g of x equals e dx, take x, g of ln of 2 equals, what is g of ln of 2? I'll ask Kavinu this. What is g of ln of 2?
I don't know.
So it's e to the power of ln of 2 take ln of 2. Yeah? This e and this ln can cancel out. And here we find that it's just equal to 2 take ln of 2. Yeah? And then g of 0. So here we have 2 take ln of 2. And then take away g of 0. G of 0 is just e to the x take away 0. Wait, e to the 0 take away 0. So e to the 0 is just 1, take away 0, which is just 0. So we have this. We have here 2, take ln of 2, take 1. So we just get here 1 take ln of 2. Does that make sense to everyone? Is there any questions, comments, concerns about that? All good?
Can you redo the working out for the g of ln of 2 but bigger?
Okay. So we have, I'll just write down g of x equals e to the x take x. Yeah? So g of ln of 2 is equal to e ln of 2 take away ln of 2. Do you see that these two can cancel out? And we're just left with 2 take ln of 2. Yeah? Does it make sense why they can cancel out for you guys? Okay. Makes sense for Mia. Makes sense for Carly. So that's what I get, yeah? Now it's asking me to find the integral from 0 to 1, yeah, of the original function. And it wants me to use the previous part to do that, yeah? That's why it's because I can't find the integral of ln of x plus 1. Well, I can find the integral of ln of x plus 1, but you can't find that, yeah? Because you guys are
No one
geniuses.
else.
Okay. I can find it, but you guys can't find it because I'm cool, you know. So here, right, I have to do a little bit of inspection here. So this is what it looks like, yeah? This is what it wants me to find. So it wants me to find this whole section. And now, I'm going to draw e to the x part. Actually, we'll do it on a different graph. We'll draw the e to the x ones down here. So this is what it looks like over here. And before we found this area. Now, what does this area represent on this graph? Can anyone see it? I dare you all to turn your head 90 degrees and see if you can see it. Mia, do you think you know? Kavinu, Carly, anyone? Anyone think they know?
Is it like the area on the top because they're inverse?
Are you scared?
Like,
It's this area. Because I turn my head 90 degrees, and it literally looks like this function, but just reflected, yeah? So, the thing that I want you to take away here is that for the inverse function, what this area finds is what this is just the rectangle, like, what is it? What this area finds can help you find the area of this one. Because you see that this just makes up a rectangle, yeah? This rectangle has a length of 1 and a height of ln of 2, yeah? The length of 1 and a height of ln of 2. And if I take away this part away from it, the black part, I then can find the blue part. Does that make sense for everyone? Is that all good? Is that like locked in? Does it make sense? Okay. So that's like the logic behind this one, yeah? I think this, as well as one other section of integration, will probably be the hard parts that they give you. If they give you an integration test, this is where your integration-based SAC will probably utilize this one at least once because they're mean. And the best way to think about it is to literally turn your head 90 degrees and be like, oh my god, they look the same, right? It's a bit stupid, but like, hey, it works. So, I'll just move on to these last two slides. This is the average value of the function. Now, this is the integral definition. All it's saying is that the area under this curve, if we find the area under this curve and divide it by the length, right, we can find out the average value of a function, yeah? And the average value is just the average height of it's just the average height of the function. That's what you can think about it as. It's the average height of the function, yeah? The average value is the average height of the function. So here, if the average value is 2, the average height of this function is 2. Any questions about that at all? So I want you to remember that this is an integral definition, yeah? But sometimes what they'll do is that they'll just give you a bunch of shapes, you know? Like, for example, they'll be like, oh, what's the average value of this function? yeah? And you can see that it's either two triangles or one triangle, yeah? And you can find the area of the triangle and then divide it by its length to find the average value. Does that make sense for everyone? All good, all good, okay. So we'll have a go at one of these average value ones. So here, find the average value of x squared for the interval 0 to 2. Illustrate with a horizontal line to determine by this value. So here, we do the formula. So y average equals 1 to over 2, take 0, the integral from 0 to 2, x squared dx. Yeah? So this is just the definition here. Then I evaluate this integral. So I can simplify the outside to a half. Brackets x cubed over 2 over 3. 2, 0. We get f of x is x cubed over 3. F of 2 equals 8 over 3. F of 0 equals 0. So we get here a half. F of 2 take f of 0, which is just equal to a half. 8 over 3 take 0, which is just 4 over 3. Yeah? So here, if I sketch out this function from 0 to 2, so this is 2 here. What it's telling me when it says illustrate with a horizontal line determined by this value. Essentially, the horizontal line is just going to be a dotted line at y equals 4 on 3. Because it's just that average height. The average height of the function. So, people have a tendency to mix up the average value and the average rate of change. Please don't. The average rate of change uses a different formula. Yeah? The average rate of change is just the f of b take f of a over b minus a. The average value uses this integral formula, or alternatively, if you're able to just find the area under the curve and then divide it by the length, then you can also find the average value. So, does anyone have any questions about that whatsoever? Is that all good? So, for the rest of the time that we have, we'll just do some questions. Yeah. How has everyone found these 3 lessons? Is it like overwhelming? Is it like too much? Is it too little? Do you want more stuff like this? Do you want less? What do you guys think?
I don't think I memorized anything.
The honestly, the main goal of this wasn't for you to completely master it. I'll say that. Like, it's not for you to completely master it. It's for you to see, like, to be familiar with integration and familiar with differentiation. So then when you step back into it, it's not like, oh my god, there's so much new stuff. It's like, oh my god, right? I can just focus on the working out. I don't have to focus on the logic behind it. Yeah? I can just follow the process, yeah? And like, yeah, so the goal is just ultimately make you as familiar with the topic as possible, yeah? So that when you do step into it, you don't feel overwhelmed. Because like the worst thing is feeling overwhelmed. Like I remember I hated English because it was always just like some random bullcrap and I could never figure out what the fuck they were doing half the time. And it's so bullshit. I still don't get it. Like I have 2 friends who are 50s and I still don't understand what they're talking about. Right? 2.
Last one.
Yeah.
Anything else?
It's getting hated on here, bro. First, I'm gonna get slimed by someone. I'm gonna get slimed by like 6 people when I see them if I see them in person. They'll see me a Monash. Dude, I'm gonna die.
You just get bullied everywhere at this point.
So let's have a go at some questions. These are real exam questions, by the way. This is during the Unk ages of 2006. You guys weren't even born then. Ah.
You were born in like the 90s, so I don't know.
Okay, bro. Calm down. So, Carly, I'll get you to do this one. Yeah? Here. What is the derivative of this function?
Bruh. Wait, so it's is it e to the power of cos x times by cos x?
Not cos. What's the derivative of cos x?
Oh, bruh. Negative sine x.
Yeah, negative sine x. So this is just negative sine x e cos x. Does that make sense? So Mia, I'll ask you to do this one. What's the derivative of this function evaluated x equals pi 6? So how can I first find dy and dx?
Do I need separated? Oh yeah. So you would be around y would be tan of u.
So not so
Oh,
this
v
is yeah. So we do
other one,
yeah. So
and then
this is a quotient rule. Why is it a quotient rule?
quotient rule.
No, product rule. Sorry.
Oh, product rule. Is the times together,
Yeah, the times together. So
and then u dash would be 1, and then v dash would be Oh, I have notes. Wait,
it's on your formula sheet as well.
I don't have that.
Oh, God.
Oh, is it the? Oh, wait. 1 over cos squared x.
Yeah, 1 over cos squared x. So, what does dy on dx equal to then?
Would it be x over cos squared x plus
Yep, plus.
tan x?
Yep. And then, what is that value at x equals pi on 6? So what does x get replaced with?
Pi on 6.
So pi on 6. Here we have cos squared of pi on 6, right? What is cos of pi on 6?
Hold on. Is it root 3 on 2?
Yeah, root 3 on 2, and because it's cos squared, it's root 3 on 2 squared. Yeah? Plus, what's tan of pi on 6?
Would it be 1 on root 3?
Yeah, 1 on root 3. So that means here, what we're left with is pi on 6 over 3 over 4 plus 1 on root 3. So then how can we simplify this?
Do I have to take out a common something?
No, do you know how to simplify these sort of fractions?
Times them?
So here, this becomes pi on 6 divided by 3 on 4 plus 1 on root 3. How can we actually use this?
Times those two together, like flip it.
Yeah, flip it. So we can flip it. We get pi on 6 times 4 over 3 plus 1 on root 3. And then what do we get?
4 pi on 18 plus 1 on root 3.
How can we simplify that 4 pi on 18?
2 pi on 9.
2 pi on 9 plus 1 over root 3. Does that make sense?
Yep.
What about for Carly and Kavini? Is that all good for the two of you? So, it's raining out here. So, this one here. A rectangle XYZW has two vertices X and W on the x-axis and the other two vertexes Y and Z on the graph of y equals 9 take 3x squared, as shown below. The coordinates of Z are A, B, where A and B are positive real numbers. Find the area A of rectangle XYZW in terms of A. So, Carly, how can I find the area of this rectangle?
So you'd find like the width and the height. So it'd be negative A plus A.
Which is?
0. Wait, what? No. What? Oh, wait, is it not 2A?
It's 2x. So it's A
Right.
take A. A take minus A.
Okay, yeah, 2A times B.
And how can we write B into something we can use?
Bro, I don't know.
How can I write it in terms of A?
No, ask me.
I don't know.
So here we're told the equation, right? We know that A equals X. So that means here, this is A, comma, 9 take away 3A squared, right? Does that make sense for the two of you? So here, B is just 9 take away 3A squared, which means the area of this is going to be 2A brackets 9 take away 3A squared. So, Kavinu, how can I find the maximum value of A? And the value of A which this occurs.
You have to find the derivative.
So how can I turn A into a form I can differentiate?
You can expand it out.
So I get A equals
18a minus 6a cubed.
so then what's the derivative?
18 minus 18a squared.
So, and here what I do is how can I find the maximum, Carly? How can I find the maximum of a function using the derivative?
Were you teaching this yesterday?
Yes. No. Yes? No, I think I did it on the first day of on the second day of differentiation.
I don't remember.
Mia, do you remember what I can do, like derivative equal to?
Can't I just let it equal 0?
Yeah. See that? So I do here 0 equals 18, take away 18, a squared, which is just, how can I solve this one, Kavinu? Just getting aired out now. I really did get aired out. So I get 18, 1 take away, oh, let me just solve this normally. This is negative 18, negative 18 a squared. I can divide both sides by 18, so we get 1. And we get a equals plus or minus 1. But then here, I need to remember that a and b are positive real numbers. So that means here, hence, a equals positive 1 as a is greater than 0. Yeah? So that means here, I can substitute in that value. So I can sub a equals 1 into here. And I get 18, take away 6. So I get 12 as my maximum. So hence, max area is 12 when a equals 1. Does that make sense? Does that make sense for you guys? Okay. So here, I'll ask Carly, when is f dash of x negative? What interval is f dash of x negative?
Bro, stop asking me. Is it 0? Wait, 1 to 4.
So 1 to 4 is when f of x is negative.
Oh, brush. Bro, I don't know. Stop asking me, please.
Okay. So it's when, so it's between negative 3 and 3, right? Because this is when the tangent line is negative. After 3, it's positive. And before 3, it's also, before negative 3, it's also positive. So Mia, which answer option would I have to choose? A, B, C, or D? Or E?
Is it a
It's A. Because it's asking when it's negative, so we're not including when the gradient is 0. So here, Kavinu, how can I do this question here?
Question 20.
Yeah.
It's just chain rule.
Alright, well, do the chain rule.
Okay, u is sine x, sine 4x, and y is f of u.
Yeah.
So the derivative u dash or du on dx or whatever is 4 cos 4 cos of 4x.
Yep.
And then that's just f dash of u, which is f dash of sine 4x.
So then the
And
answer.
then you just times the two things together.
Yep. So we get here f dash of sine of 4x times by 4 cos of 4x. And then hence we get answer option
E.
E. So if you wanted to do this using the quick chain rule, right? What you can do is you can remember that the inside function, the outside function is f of x. So here we start off by finding the derivative of the outside function. So the outside function is just f dash of sine of 4x. Then we multiply it by the derivative of the inside function, which is just 4 cos of 4x. So does that make sense for everyone? Is that all good? Okay. So, Mia, how would I go about doing this one here?
which rule would this be?
So you have,
Quotient?
yeah, quotient, because it's the quotient of two functions.
Let me find.
So you get, what is u equal then?
U would be x to the 3, and then v would be sine of x, and then u dash would be 3x squared, and then v dash would be negative cos x.
It's not negative cos x. Positive.
Oh.
Cos x. So I would start looking at the formula sheet because you'll start mixing up the trig functions.
Yeah.
So here,
And then I would do sine x times 3x squared minus x cubed times by cos x all over sine x squared.
yeah, so sine squared x, which just simplifies to 2x squared, wait, 3x squared sine x take x cubed cos x over sine squared x. Does that make sense? Is that all good? Is that all positive? Yippee. So, Carly, how can I do this question here? Fuck.
First you differentiate g of x. So it'd be so it'd be 1 over tan of x. And then you sub pi over 4 in.
So remember the chain rule.
Oh, bro, times cos squared x.
1 over cos squared x.
Oh, I guess.
Do you guys have the formula sheet with you?
No.
I have to have it on the side. Make sure you have the formula sheet with you. It'll help you a lot with diff because you don't have to memorize these formulas. You just have to know how to use them. So then, right, you said you were substituting in pi on 4. What is 1 over 10 of pi on 4?
1.
Yeah, 1. Times that by, what's 1 times cos squared of pi on 4?
It would be root 2 on 2 squared, which is 2 over 4. So half.
Yeah, so you get here 1 times 1 over 1 times 1 over half, which is equal to
2.
2. Okay. So, Kavinu, right? Here's this one, right? This one comes to differentiability. How can I sketch the derivative of this function?
Well, it's starting positive, so we're line down coming to -3
Yeah. So here,
on
what
the
we
derivative.
see is the gradient of this one is positive, right? So it's going to be, the derivative starts like this and then touches the x-axis intercept at -3 because that's when it has a turning point. Then what does it do, Kavini?
Then it continues going down because the gradient's negative.
And at 0, what happens?
It's non-inclusive because it's a sudden change, which means it's non-inclusive.
Yeah, because it's a sharp point here, it's not inclusive. Yeah?
Mhm.
So then, what does the derivative of this function become?
Well, it's just a line because it's a constant increase, so it's a positive line.
Yeah, so it's a positive line. Does that make sense for the two of you, Carly, Mia? Why the derivative of the straight line is just a horizontal straight line? Makes sense for you, Carly?
Bro, the thing's not clicking.
Like clicking as in like it doesn't make sense?
No, as in my stupid thumbs up button.
Okay. And then what happens here with this one? Give me-
It's at the 0 point. Yeah, that one. Because the gradient is 0, which means it's on the line.
Yeah, so it's exactly on the line y equals x. So does that make sense how I've sketched it out? So here, I don't include sharp points or points of discontinuity, yeah? Sharp points and points of discontinuity, I don't put them in my derivative function. So then, I'll ask Mia, what is the domain of this derivative? Oh wait, I'll remove the endpoint since there's no endpoint.
Would it be negative infinity? Um, Zero non-inclusive union, non-inclusive zero to infinity.
It's to 3
Oh, and
union.
then infinity.
Yeah, so then it's 3 to infinity. So essentially, it's all of this part, so negative infinity to 0, union 0 to 3, right? Because it goes from 0 to 3, not inclusive. And then union 3 to infinity. Or if you wanted to write this out a little bit nicer, x is an element of R, not including, remember that's what the back arrow, the backslash means, 0, comma 3. Is that all good for everyone? So here, the graph of f where of f of x equals e to the x over 2 plus 1 is shown. The normal line to the graph of f where it crosses y equals x, the y-axis is shown. Yeah? Find the equation of the normal line in the graph of f where it crosses. Mia, how can I find the equation of how can I find the equation of the normal line using the information that I've been told?
Do I find the derivative and then sub in the point that I want and then find the minus 1 over m?
Yeah. So here, what's the derivative?
X over 2e. Oh, wait. Is it just e to the x over 2 plus nothing?
So it's e to the x over 2. We're forgetting one thing. Starts with a C, ends
Minus,
with
oh, what?
it starts with a C, ends with an ain, and has a rule. Chain rule.
Oh.
So we divide it by 2. Yeah? So it's f dash of x equals e to the power of x over 2 over 2. Then what do I do?
Sub in the point that it asked for.
So what point was that?
When x equals 0.
Yeah. So here we do f dash of 0. So what does that equal?
Is it 1 over 2?
Yeah. And then how do we find the gradient of the normal line?
Is it negative 1 over a half?
Which is,
Negative 2?
so then we can do here y equals, y take y1 equals mx take x1. So here, what is y, how can we find x1 and y1?
Is this still me?
Yeah.
Oh. Is it the y-intercept or no?
Yeah, because it's where it crosses through. So what's that y-intercept?
0, 1.
0, 2. Because if we
What?
because f of 0 equals e to the 0 plus 1, which is just 2.
Oh yeah.
So we get here, y take 2 equals negative 2 x take away 0, which is just y equals
Minus 2x plus 2. I mean.
Yep.
Yeah.
minus 2x plus 2. Does that make sense for everyone? So, Carly, how can I find the average rate of change of this function from x equals 0 and x equals 3? Just remember, it's an exam 2. So what do I have to my disposal?
Your CAS.
Yes! Incredible, Cole.
Yay. So actually, I don't remember the average rate of change formula. So
So, it's the f of b take f of a over b minus a.
okay.
What was
So-
that?
It was clearing my throat. Am I doing this on my CAS?
Yeah.
Okay, wait.
So we do it on CAS. Everyone do it on the CAS. You just pull out the CAS. All of you guys are surprisingly slow at using a CAS. But it's basically a mobile phone with extra steps. Come on, guys. You're making the Anka beat you in technology. Come on, guys. You gotta speed up. I've already typed it in.
Wait. Okay, wait.
So what did you get? What did you guys get?
C.
What?
C.
Okay, yeah, C. It is C. Kavinu, how can I do this one here?
You would probably want to draw a graph.
Yeah. So how would I be able to draw a graph here?
Well, you know the derivative at f of 3 is 0, which means it's flat there.
Yep.
And then, but it's less than 0 when it's less than 3, so it's negative gradient.
This. Yep.
Yeah, and then after that, it's positive gradient.
So then what do we get?
So it's a stationary point of inflection.
Does that make sense for you too? What about this one? Mia, how can I find for which the gradient is a negative?
Should I graph it?
Yeah. Go ahead. Graph it. You have the calculator to your disposal. Come on, guys. It's just the calculator. It's like the second coolest tool that you guys have. Like, think about it. No other subject has to bring a literal computer into their exams. You know, you guys can download games on your CAS. I probably shouldn't tell you guys that. Someone's, I can like guess that one of you guys is gonna put games on your CAS, and then they're gonna get caught with games on their CAS in the exam, and then I'm gonna have someone call me being like, "Why did you tell them to put games on their calculator?" It's like, I didn't. I swear. It wasn't me. So, what did you get for the interval?
It's supposed to be when the graph goes down, right?
Yeah. Why can't I play games during the exam? It's not. It's. I mean, it's technically not cheating. You can. Don't. Please don't get any ideas. Please don't play games in your CAS. You'll get bad street rep. That's why. I remember I had a friend who like got games on his CAS. He was like flexing about it. It was funny. It's funny for a time. Have you guys ever watched Mulan?
Dude, I don't know how to find this.
Bro, Mulan's my favorite movie ever. You know it.
Did you like Milan too?
Mulan.
I cried in Mulan too.
Well, that's embarrassing. I only realized Mulan 2 was a real movie in year 8 because back then I thought it was a fever dream that I had.
What's it about?
Like the emperor trying to marry his 3 daughters to like another empire to like preserve peace.
Okay, let me just let's get back to the math guy.
Yeah, so I don't know how to find the math.
So let's have the CAS here, yeah? So if I do graph trace 1, right? If I go all the way down, I can see that the minimum is going to be at 0.5, yeah?
That's not what my graph looks like.
Did you type in this rule?
I probably did it wrong. I forgot a square.
Yeah, but Mulan 2 is so good. Like, the only thing that like I cried when
Is it
Shang
the
died.
daughters?
What?
Who are the daughters?
It's the Ling Ling. Oh, what's their name?
What are their names?
So yeah. Did you get the correct sketch for the graph now?
Oh, yeah. I
Yeah.
think.
So then, right, you go all the way down here. This is the minimum, right? And then between the minimum and the maximum, it will be decreasing. Yeah? So between -5 and 0.5, that's going to be decreasing. Does that make sense?
Yeah.
Does that make sense for the two of you as well? For Kavini and Carly? Perfect. So here, what's the answer going to be? A, B, C, or D, or E?
I can't see the options.
Nice one, Ike.
Right. Alright, what'd you guys get?
D.
D. So, have a go at these two. Carly, how do you find the derivatives top one?
Wait. Okay, use x to the power 5 and then these 3x squared minus 5x. So then it would be Wait, what? Okay, it'd be 3x squared minus 5x to the power of... Wait, what the fuck am I doing? Okay, wait. It'd be... Wait, no, would it not be... Wait. Am I tweaking? Would it not be 3x squared minus 5x to the power of 5 times 6x minus 5?
So what's
Nice
the... So remember, you have to multiply by the outside function first.
Multiply by the outside... Wait.
So do the derivative of the outside function first.
Oh, 5.
Yeah, so it's 5.
Okay. 5. Oh, wait. Oh, that's what it is. Okay. 5, 3x squared minus 5x to the power of 4, then times 6x minus 5.
Yeah, perfect. What about this one here?
Me again?
Yep.
Oh, okay.
So what do you do here?
Oh, Mia, shut up. Bro, Mia's such a hater. Actually, shut up. Okay. So it'd be... Wait a minute. So it's the outside function x, and then the inside function.
So is this one chain rule, or is it?
Oh, product.
So what is u equal to?
U is x, and then v is e to the power of 3x. So then u dash would be 1. And then v dash would be 3 to the power... 3e to the power of 3x.
So then, what is f dash x?
So it would be x times 3 e to the power of 3x times... Wait, plus e to the power of 3x.
We do f dash of,
0.
which is just is equal to
2. Wait, 5. Wait, no. 4. Mia, shut up.
So, because this is 0 times e to the power of, 3e to the power of 3,
Wait,
3e
0.
So this part's 0, yeah?
Yeah, wait. And then plus 1, which is 1.
Dude.
Dude. Bro, Mia, shut up. Mia's such a hater. Actually, Mia should do all the other questions.
Mia, you should have go with this one.
Is it already my turn?
Yeah.
Write down the domain of the derivative function. Oh, I don't want to do that.
So where is the domain not inclusive?
At x equals 1.
Yeah, so here it's at
So all real except for 1,
and
2.
2. Does that make
Ooh.
sense for everyone? It's because here, this is a point of discontinuity and this is a sharp point. how can I do this? So the plastic brick is made in the shape of a rectangle, a right triangular prism. The triangular end is an equilateral triangle with side lengths x centimeters, and the length of the brick is y. The volume of the brick is 1,000 centimeters. Find an expression of y in terms of x.
So you want me to find the expression? Okay, well, all you have to do is it's 3xy, right?
So 3x.
The volume, yeah, equals v, which is 1,000, right?
Where did you
So
get
y
this
is
3xy from?
1,000 on 3x.
Where did you get this 3xy from?
I mean, not 3xy, sorry. It's not 3x. It's 1/2 of x squared sine 60.
So I'll explain this formula that Kavinu has used. Yeah. So do you guys have your best friend with you? Your good friend, not your best friend. Your best friend's your chemistry data forever. Your good friend is your methods formula sheet. So there's two formulas you can use here. Yeah. Of course it just want to pull up. So the first formula you can use is, because it's an equilateral triangle, if I cut it in half, right, I get x over 2. I can find out the height of this triangle by using Pythag, yeah? Because I have x squared, take away x squared over 2, all square rooted. The other way I can do this is I can use the formula, right, to find the area of the face of this. The area of this face is going to be 1/2 AB sine of C, yeah? So essentially, right, what AB sine of C means is that if we know 2 points, right, if we know that 2 side lengths connecting to each other, and we also know the angle between these two, which is going to be, what's the angle between these two, Mia? What prompt in the stimulus tells you what the angle between the two is?
It's an equilateral.
So that means it has an angle of
Is it 60?
pi over 3. Yeah? So we get A equals 1/2 times x times sine of pi over 3. Does that make sense?
Why can't we just use 60? It's the same.
Because we think in radians, my boy.
Yeah, shush.
Think in radians. So we get here, sine of pi on 3 is just root 3 on 2. So this just turns into root 3 over 2. So we get here root 3 x squared over 4, right? So then the volume of this is just going to be the face times by the length of this, which is just going to be the volume is equal to root 3 x squared over 4 times y. But we know the volume here is 1,000. So that means we get here 4,000 divided by the square root of x over 3 equals y. Does that make sense to everyone? So, I don't even want to do this part. So, we'll finish off this part, yeah? How can I write an expression for the surface area of this object? Carly, how can I'll get you to start us off. How can I find the surface area of this object in terms of x and y?
So be 2 times root 3x squared over 4.
Yeah, because of the two triangles. Yeah.
Yeah.
What else?
Then also 3 times x times y.
Yeah, 3 times x. So 3 plus 3 times x times y. So the surface area of that one. Yeah. So I usually write surface area using SA. That sounds really bad. Ignore the connotations behind the word SA. Here we write down root 3 x squared over 2 plus 3 xy. So that's what this simplifies to. But we know that y equals 4,000 over the square root of 3x. Is it x squared? Yeah, x squared. So, what does the surface area of this object become in terms of x column?
Okay, so sub the line, so it'd be root 3x squared over 2 plus 3x times 4,000 over root 3 x squared.
Yeah. And then how can we simplify this? Because this
Bro, I don't know.
part's already simplified. So we have the 3, and then we have a root 3 down the bottom. What does that become?
Oh, root 3 on 3. What?
So 3 divided by root 3.
Yeah. So then do I have to also
This just
do
becomes
things
root
with...
3.
Oh.
And then do the same thing. Is there anything else we can cancel out over here?
They're x. They're x.
Yeah,
Yeah.
so we get here 4,000 root 3 over x, because the x's will cancel out with one another, and we'll just be left with 1x down the bottom. And this root 3 will disappear after it's divided. So after we do 3 divided by root 3, we just left with root 3, so we're left with this expression. Does that make sense? Is that all good? So then, it says here, find the value for which the brick has a minimum total surface area. Kavinu, how can I write the surface area in a form that we can differentiate a little bit nicer? Because we know it's a minimum, we have to use derivatives.
You could get the same denominator, I guess. I don't know.
No, what are we doing to this x? So we get here root 3 x squared over 2 plus 4,000 root 3 x to the power of negative 1.
Oh, okay. Yeah.
So we get into a form we can easily differentiate. Now how can we, what is the variable that we write this as? It's d of
dA on dx.
So here I've defined it as SA. So it's dSA over dx equals, what do we get?
2 square root 3 on x.
So square root 3 on x, yeah? Square root
Yeah.
3x.
Because the 2's cancel out.
Yeah.
Plus, well, minus actually. Minus 4,000 root 3 on x squared. Or x to the negative 2.
So then I'll ask Mia, how do we find out when it's a minimum?
Let it equal 0.
Yeah, so then we have 0 equals this whole expression. But then how can we solve this expression?
Should we factor it out?
Yeah, so what would you factor out?
Can I take out the root 3 and x?
So we take out the root 3 and x. So we have a root 3 and x. So we're left with 1 take 4,000. What does this become? X to the
-1.
no minus 1 because we're factorizing it out. Yeah, becomes
Uh,
-3.
okay.
Does that make sense? What?
Yeah, I think so.
So then, what can x be equal to then? I mean, what can 0? What is 0 equal to then?
Me?
Yeah.
Root 3x or 1 minus 4,000x to the 3, -3.
So then, if we solve this one, we get x equals 0, but no, so this one's not a minimum. This one isn't a minimum because this approaches infinity, right? Or it's not defined in the domain technically. So it's not a solution as x is greater than 0. Yeah. And then this one over here, right? We can solve this one. We get -1 equals -4,000 over x cubed. Then what we can do is we can do 1 over 4,000 equals x cubed, which means here, x to the, 1 over x cubed. Then we get x cubed equals 4,000, which means that x equals the cube root of 4,000. And that's all we need, because it's only asking us for the x value. And it says do not find the minimum, because I wouldn't want to have to sub in x equals the cube root of 4,000 into my expression. So, I know we went a bit over time today, but I'll wrap things up. How did everyone find today?